Okay, we're continuing with integration by parts, and this time we're doing the recursive method. And I wrote an example, e to the x sine of x dx. So what is this exponential times sine or cosine? There's a significance in that when you're doing physics or engineering related to physics, basically. And that is basically it should be e to the power a negative times coefficient times x. And sine and cosine usually have something inside of them beside x. So the period is not 2 pi in that case. But anyway, the significance is that you get this oscillation, damped oscillation with these type of functions. Again, it should be a negative sign in there and so on and so forth. But this is my first example that I'm doing in here, and then I want a simple type of example so you can just focus on the method that we're covering right now and not the method that you will use in the future. That would be something that you do with the arithmetic on a piece of paper to follow every step, basically. So now here integral of e to the x sine of x dx, and I'm trying to take this antiderivative, and I'm thinking, well, could this be integration by parts? And I just showed it basically an arrow in the dark, and I don't know which one to choose, if it was like a polynomial times e to the x or polynomial times sine of x. I would have been a lot more comfortable, but right now I have no idea. Turns out it doesn't matter. You can choose whichever you want. You end up with the same results, basically. So what I'm going to do is I'm going to choose u equal to e to the x and dv to be sine of x dx. And then what do I get? I get du equal to e to the x dx and v to be negative cosine of x. So I'm going to write down these two multiplied together minus the integral of the second line. And what do I get? So the first integration by parts gave me e to the x negative e to the x cosine of x minus integral of negative cosine of x e to the x dx. Okay, so this didn't do a whole lot for me. The funny part is that if I kind of have it in my gut feeling that if I continue doing the integration by parts, I will end up with e to the x sine of x. And so let's just do that, because if I end up with what I started with, maybe I can solve what I started with. And so that's actually the trick in here. So what do? This was the first integration by parts, and then I do another integration by parts, and not e to the x. Oh yeah, this time around it doesn't matter what you choose in the first one, but if you're continue with the basically either exponential to be u and the other one the trig to be dv, or however you chose the first one, basically the trig and exponential matches. And so I get on dv this time, and let's add minus times minus makes a plus, so let's keep it that way. And then I will have dv equal to cosine of x dx, and so du is going to be e to the x dx, and v is going to be sine of x, right? Derivative of sine of x is cosine of x, right? And so now this part of the integral is going to be equal to e to the x sine of x minus this integral minus e to the x sine of x dx. So let's replace that part by that, and I get negative e to the x cosine of x plus e to the x sine of x minus e to the integral of e to the x sine of x dx. Okay, this is not this is back to where I started. Is that a good thing or a bad thing? Let's think about it. So and looking at that, I see that here is the integral I'm looking for. Let's call it a, right? And that integral over here is equal to this bunch of stuff, right? And minus a again. So basically, a, which is what I want, is equal to negative ex cosine of x plus ex sine of x minus a. Oh, this is just a linear equation for a. I can solve for a. How do I solve for a? Isolate. So this a comes over here, becomes 2a. 2a is equal to negative e to the x cosine of x plus e to the x sine of x. And then a is equal to negative e to the x cosine of x plus e to the x sine of x divided by 2. And so that is the answer of the integral. So this is the recursive method. You will see there's another example that you can watch. It works with the damped oscillation. Damped oscillation is e to the power something times x and times sine of x, or e to the power something times x cosine of x. There are other methods of finding this in differential equations. You will learn that Euler's formula is useful to basically compute these in an easier manner, but it's useful overall. That's where you use it basically.